Let's say that you're in school again, but this time your teacher has the option to either give you letter grades or just a simple pass or fail grade for the class. If your teacher selects letter grades, then there will be certain ranges for each letter, and if your class grade falls within that range, you receive the corresponding letter. Conversely, the pass or fail grades depend on whether your grade is at least a C or 70%. In this more complicated grading process, there are two groups of choices that have to be made. One is the style of the grading scale, and the other is what your grade would eventually be on that scale. Now, this analogy can be directly applied in Java, and I'll show you how to do it with nested if statements. With this example, let's write a program which would print out what letter grade a student would receive or if they passed the class given their current class grade. Here I've created a new Java file called studentgrades.java. In this program, we'll continue to use if statements and print out what grade a student should receive with a given score and a given grading system. We'll do all of our work in the main method, so let's get started. First, let's declare a variable called score. This time I want a decimal value, so we'll make it a double instead of an integer. We'll worry about initializing it later when we try testing the different possible grades. We'll also need to create a Boolean value called isLetterGrade to indicate the type of grading system that will be used. If the variable is true, letter grades are used, and if false, then it means that the pass or fail system is used instead. So given these different grading systems, our first condition to check is whether the letter grading system is used or the pass-fail system is used. So let's type if isLetterGrade, two equal signs, and then true with end parentheses. And then I type two curly braces for that block of code. Notice I put two equal signs because two equal signs means that I'm comparing two data types. In this case, it is isLetterGrade and true. Otherwise, one equal sign, which we've seen before, is an assignment operator. It means something else. So for example, if we typed int num equals 7, it means that I'm assigning num to be 7. Nothing to do with comparing Boolean values in this case. Also, regarding if statements, one special thing about using Boolean variables in the condition is that we don't need to use the equal to operator because a Boolean variable by itself can be a conditional expression. Remember that no matter what you type here, it must be a Boolean expression. So we can actually delete this part. See, if the value of isLetterGrade is true, that makes this whole expression true, and the code here would run. If we wanted to check if the variable was false, all we would have to do is put the not operator, which is an exclamation mark, right before the variable like so. Put it right here, and so the exclamation point here, or the not operator, just flips the Boolean value to its other value. Now we need to write an else statement if the condition right here is not true. No else if statements are needed because luckily we just have two possibilities. So I'm going to type else with two curly braces. Let's start with the code inside the if statement. For the letter grading system, if the grade is at least 90%, then the student receives an A. So we would need to write another if statement inside this if statement, and this is referred to as a nested if statement. The condition will need to be if score greater than or equal to 90, and if that occurs, we type system.out.println, the student receives an A. Now for B, the student's grade must fall between 80 and 90, with 80 being inclusive. So to write this condition, we would need to write a compound inequality. Remember, you cannot write 80 is less than or equal to score, which is less than 90. Instead, we need to split this into two conditions. But we can keep them in the same if statement with the use of a logical operator. So in Java, there are three logical operators: and, which you've seen before, which is two and symbols; or, which is two vertical bars; and not, which I introduced earlier, which just flips the Boolean value. Before we use them in this example, here's a table demonstrating how these operators function. In the table, A and B are two different conditions, and they can be treated as two Boolean variables. As you can see, with the OR operator, which is two vertical lines, it only requires that one of the conditions has to be true for the entire expression to be true. That means if either A or B is true, then the whole expression still remains true. However, for the AND operator, both conditions need to be true. So if either A or B are false, that just automatically makes the whole expression false. And then lastly, the not operator gives the opposite of the condition's value. So if the condition is true, placing a not operator in front of it would just make it false. In our program for a B grade, we can split our compound inequality into two conditions. So we would type score greater than or equal to 80 and score less than 90. Now we need to add a logical operator. Since the score must fall inside this range, both conditions have to be true, so we would use the AND operator. If we reuse the OR operator, the else if statement wouldn't make sense, because if we had a score of, let's say, 75, the first condition would not be true while the second one would be true, and an OR operator only requires for at least one of these statements to be true, and if one of them is, that makes the whole expression true. This would not work since 75 is not in the range of 80 to 90. So we've done this example in the previous video. So if you haven't seen that video, either try typing the rest yourself or take a look at that previous tutorial video. I'm just going to paste the rest of the condition statements here since I've done them before, and it should all look pretty familiar if you've seen the previous tutorial. Just as a reminder, for an F grade, an else if statement is not required, because if all the statements above are not passed, then we know for sure that the score has to be less than 60, which is an F. Also, pay attention to how I indent the code. The nested if statements are indented further and make the code much easier to read. Now that we have gone through the whole letter grade system, let's work on the pass or fail system. We will need to write another nested if statement inside this else here at the very bottom. To pass a class, let's assume that the student just needs at least a 70% in the class and print the appropriate statements for each possibility. And so for you guys to give it a shot, pause the video, take some time to try doing this part yourself. Okay, assuming you've done it, the answer is pretty simple. If you've seen this right here, if the score is greater than or equal to 70, then you would just print out the student passes the class. Then the only other possibility within this statement is if the student fails the class. One thing to note for these expressions here where the AND operator is used is that if the first condition is false, then the whole expression is false no matter what, and the value for the second condition does not change anything. This is because the AND operator requires both conditions to be satisfied. So if the score is 75, the student fails to receive an A, and when the conditions for B are checked, the first condition is not met since it's less than 80. Even though the second condition is true, Java makes it so that it is not checked for this reason. This is called short-circuiting. Both the AND OR operators are short-circuit operators. Short-circuiting for OR is basically the same, with the difference being that the second condition won't be checked if the first is true. I mean, this makes sense. If the first condition is true and the second condition is false, the whole statement's true. If the first one's true and the second one's true, the whole thing is also true. So there's no point in checking the second condition if the first one's already true. And another thing to note is that there's many ways to write if statements and their conditions. So for instance, in this example, we can actually get rid of the AND operators and the second condition for each of these else if statements for the letter grades. Logically, the reason we don't need the second condition for each of these is because each if statement above the other ensures that the upper bound is satisfied. Saves you a lot of code to type, so which is nice. For example, if the grade score is 85, it'll fail to qualify for an A grade, guaranteeing that score is below 90. So the second condition there wasn't even necessary. Now that we have finished writing our code, let's not forget to test it. So compile it and run it with different possible values. We'll need to change the values that we initialize score and is letter grade with. So I'll just make the score first 95, and let's say is letter grade to true, since we're testing the letter grade system. So if we compile and run our code, we get A. Now let's change to 80, and it gives us B. Let's just try 50, and it gives us F. So now let's switch over to the pass or fail grades by making is letter grade false, do 75 for the score, compile and run the code. It says the student passes. Then change it to 50, compile and run the code, and it says the student fails the class. So if statements can get a little complicated, but they're pretty important when making decisions in Java code. And so to get better at them, especially when you have complicated decisions intertwined together, it's always best to practice with coding problems. See you in the next tutorial.